Hey guys, Miss McMahon here. Today we're going to find the inverses of 4 different functions. So we know that an inverse of a function is a function that undoes the original function. And we know a couple ways that we can identify a function and its inverse. One way is through a table of inputs and outputs. We know that the table's inputs and outputs should be opposite of the inverse's inputs and outputs. The inputs and outputs should switch places. We can identify it on a graph because a function and its inverse should reflect over the line y equals x. And so if we see y equals x as the line of symmetry on a graph, then we can identify that function and its inverse are in fact just that, a function and its inverse. We're going to find these inverses algebraically, but rather than doing it procedurally where you switch the variables of the function and solve, we're actually going to take a look at what operations are happening to the input in what order, and how can we inverse and reverse those to find the inverse function. So you see what I mean when we get to the first example. So here we go. So we've got g of x is negative 2x plus 8, and we're going to think about this in terms of what happens to the function if we were to input something in for x. If I were to plug a value into the input, into the x variable there, what would happen to it? And to do this correctly, we need to remember and be very aware of order of operations. Because order of operations does cause certain things to happen to x first or second or last, based on what operations are taking place when we would plug something into x. So again, if we plugged any number into x, the first thing that would happen is we would take that input and we would multiply it by negative 2. So we're going to make a list here, and the first thing that would happen if we plug something into the g of x function is that we would multiply it by negative 2. We would take that input and we would multiply it by a negative 2. And the second thing that would happen is we would add 8. So if we plug something in for x, the first thing that we would do is we would multiply it by negative 2. And then we would add 8. And that is the order, according to order of operations, that we would change our input based on the function that we're working with. Now, to find the inverse, we have to do two things. We have to, first of all, we have to inverse both of these operations. So we have to do the inverse of multiplication is division, and we have to do the inverse of addition is subtraction. But we also have to reverse the order that these two operations happen in, and that's because of order of operations. Because in finding the inverse function, we have to completely undo the original function. And so that not only means reversing the two operations, like I said, but also reversing the order. So that means that for the inverse, the first thing that we're going to do to some input in the inverse is we're going to subtract 8. And then the second thing that we're going to do to that input, after we plug in an input and we subtract 8, then we're going to divide it by negative 2. And so with that, we're going to write an inverse function. So again, we take some input and we're going to subtract 8 from it. And then we're going to divide that by negative 2. And so there we have our inverse function. And there's a couple different ways you could write this. You could write this as, maybe negative 1/2 x plus 4. There are a few different ways that you could write it, but here we have our inverse function of g of x, because we identified the two things that were happening to the input in the original function. We inversed and reversed those operations to get our inverse. So we're going to do more practice. We're going to do this with the remaining three functions, but we have our inverse function of g of x is some input minus 8 divided by -2. Okay, so moving on to f of x, which is the cube root of -x plus 3, and I have my order of operations here in the corner because I want to keep in mind that I have to follow that and use that to evaluate a function correctly, and then also to undo everything about a function to find its inverse. So again, I'm going to make a list, I'm going to make a table of everything that happens to the input being x, everything that happens to the input in the correct order so that I can inverse and reverse it to find the inverse of f of x. So if we were to plug something in, if we were to plug some number in, any number in for x, the first thing that we would do to that input in the f of x function is we would multiply that by -1 because of this negative, and really there's a 1 right here. We just don't always write it. It's one of our pieces of invisible math, but we have a -1 being multiplied by x right there. So that would be the first thing that we would do to an input in the f of x function. The next thing that we would do is we would add 3 to that value. And then the last thing that we would do is we would take the cube root of that value. So if we're looking for the inverse function of f of x, we are going to do two things. We're going to inverse all of these individual operations. We're also going to reverse the order. So for the inverse, we would have some input, and then the very first thing that we would do to that is the inverse of a cube root, which is a cube. We would cube the input. Then the next thing that we would do, instead of adding 3, we'll need to subtract 3. And then the last thing we will need is, instead of multiplying by -1, we're going to need to divide by -1. Now, that is actually the exact same thing as multiplying by -1. So that one doesn't really matter, but if you want to think about it as the inverse operation, you can certainly think about it as dividing by -1. So if we take some input, and the first thing we're going to do is cube it, and then we're going to subtract 3 from it, and then we're going to divide by -1. And again, there are different ways that we could write this. We could work to simplify it from here. And I really would encourage that, because leaving a dividing by -1 is not the best way to look at this function. You wouldn't see that in any sort of multiple choice simplified version. Instead, you would see x cubed divided by -1 is negative x cubed, and then -3 divided by -1 is going to be a plus 3. So you would see negative x cubed plus 3. And so there we have our inverse of the f of x function. We're going to take a look at two more. All right, so moving on to h of x. We have the h of x function is negative quantity x minus 2 squared. And again, I just want to keep order of operations at the forefront of my brain as I work through this, not only evaluating what happens, what operations happen in h of x and in what order, but then how to undo and reverse that order for the inverse. So in the h of x function, again, if we were to plug any number into the input x in the h of x function, the first thing that we would have to do following order of operations is what's in the parentheses. So the first thing that we would have to do to some number that we plugged into the input x is we'd have to subtract 2 from it. We'd have to take away 2 from whatever input we plugged in. And then, and again, this is where the order of operations becomes really important. The next thing that we would have to do is square it, because exponents come before multiplication. So the second thing that we would have to do is we'd have to square that value. And then the last thing that we would have to do is multiply by -1, because that negative could be a -1. It was just invisible. We weren't bothering to write it, but what's happening is all of this is being multiplied by a -1. And so for the inverse, we have to inverse all of these operations, and we have to reverse the order. And so instead of multiplying by a -1 last, we're going to divide by -1 first. And again, multiplying by -1 and dividing by -1 is actually the same thing, only for the numbers 1 and -1. So that doesn't matter too much, but again, being consistent with the idea of inversing each operation, if you want to think about it as division rather than multiplication, I say go for it. The next thing that we have to undo is the square, and we have to be really careful here because the inverse of a square is a square root. So then we'll need to square root the input of the inverse, but we have to remember that there's a positive and negative value that comes from that. And that's really tricky and easy to forget. So we want to be really careful there that we don't drop that positive or negative, positive and negative value. And then lastly, we're going to inverse subtracting 2, and we're going to do that by adding 2. So that's going to give us an inverse where we have some input, which we typically call x, and we are going to divide that by -1. And then we're going to, I guess I didn't really leave myself enough room right here, then we're going to square root that with a positive and negative value. And we have to be really careful here that we square root everything we have so far. So we're square rooting the entire fraction, and that's because we need to make sure that we're taking the square root, we're doing this step of every piece of the function we have so far. And that goes back to that order of operations, is making sure that you are not only taking the inverse of each operation here, but that you're reversing the order that these steps were done in, which means that you're taking the square root of everything that you have so far, which what we had so far was the input divided by -1. And then lastly, after taking the square root with the positive and negative values, then we're going to add 2. And this part is going to go outside of the square root, because that came after the square root. So it's not in the square root, it's outside of the square root. And sometimes you see these tails on square roots to help us visualize what is in a square root or any kind of root, and what is not in that root. So it just helps us with the visualization of the proper function. The last thing that I would do to simplify this, that I'll do over here, is I would just say that x divided by -1 is -1 times x, since that's the same thing. So we've got the inverse of h of x is plus or minus the square root of -x plus 2. And there we have it. All right, one more. All right, so the final function that we're going to find the inverse of is n of x, and that function is -2 plus 3/2 x. Again, we're going to make sure that we keep order of operations at the forefront of our minds as we do this work. And you probably noticed that I wrote order of operations a little bit differently than I have so far this video. And the reason I did that, some people write order of operations this way, and that is because multiplication and division happen at the same time, moving from left to right. And addition and subtraction also happen at the same time, moving from left to right. So if those two sets of operations were the only things, if one of those two sets of operations was the only thing that you had in your equation, you could do it just moving from left to right, the same way that we read a word or a sentence. So again, thinking about what would happen if we plugged some value in for x, what would we have to do to that input first? The first thing that we would do is we would multiply that value by 3/2. And I'm going to break this up into two separate operations. Again, because multiplication and division happen at the same time from left to right, I'm going to say first we would multiply the input value that we have by 3. And then second, we would divide that input value by 2. And then the last thing that would happen is we would add -2, which is just subtracting 2. So we have 3 things that would happen to the input upon plugging some number in. And to find the inverse, again, we're going to inverse each individual operation and reverse the order. So the first thing that we would have to do for the inverse, after having some input x, we would need to add 2 to it. The second thing we would need to do is, instead of dividing by 2, we would need to multiply by 2. And the third thing that we would need to do, instead of multiplying by 3, we would need to divide by 3. And so with that, we're going to write the inverse function, the inverse of n of x. So we're going to take some input, x, and add 2 to it. And then we're going to take all of that. We have to take the input and the first step, and we have to multiply all of that by 2. So I'm going to put parentheses in and multiply that by 2 so that the 2 is being multiplied by the x and the 2, and not just one of those pieces of that expression. And then the last thing that we need to do, and again, we need to do this to all the steps we have so far. So the entire expression we have written so far is going to be divided by 3. So we're going to divide everything we have by 3. And there is our inverse equation, our inverse function. And the only thing that we might do to simplify this a little bit, because I kind of doubt you would see it like this in say a multiple choice question. The only thing we might do to simplify is distribute the 2 through the parentheses, which would get us 2 times x is 2x, plus 2 times 2 is 4, and then that all is still being divided by 3. And so there we have a slightly more simplified function of the n of x. Function is 2x plus 4 divided by 3. So I hope this video helped. I hope you were able to look at inverses and specifically how to find them algebraically through another lens, where it's maybe not so much a procedure that you need to memorize, but really a process of undoing every single operation that's happening within the function and reversing that order to undo order of operations, so that in the end you get an inverse function that completely cancels out the original function. So let me know if you have any questions, if there's any other way that I can support everyone. But other than that, have a good day. Thanks. Bye.